In many application scenarios, we expect robots to explore the world for us and we want to know the status of robots constantly. But when network disruption occurs, valuable information is lost due to limited memory. Take rows as example. There is an internal buffer. When network disruption occurs, the internal buffer becomes full eventually, and rows discards the oldest message to make room for newer messages. As a result, a long segment of messages is lost. This solution is called the drop oldest buffer management policy. This is not preferred in many scenarios. We make a new assumption that uniformly sampled messages are more valuable than the newest messages. Our goal is to use the internal buffer inside robots more efficiently, keep more valuable information, and be more resilient against temporary network disruption. In order to accomplish that, we propose a novel buffer management policy named OptSample. By using the OptSample policy, we can avoid losing long segments of messages and be more resilient against network disruption. We define an evaluation function to estimate the profit of a received message sequence. We prove and show with simulation that our OptSample policy can get results bounded close to the unfeasible Oracle policy. We implement our OptSample policy in rows. The implementation is transparent to the user and can be used with all the applications with the same API. We test our OptSample policy with several applications including surveillance, 3D reconstruction and SLAM. The first application is surveillance. Surveillance images are taken by a robot and sent back to the control center. The network is disrupted for about 4 seconds. With native rows, a long segment of messages is lost and the attacker manages to avoid being captured by any images. With the OptSample policy, the attacker is captured in a few images and these images provide clues of the attacker. The second application is 3D reconstruction. We implement a rows node for the infinitum algorithm. The network is disrupted for about 5 seconds. With native rows, a long segment of messages is lost and infinitum fails to find the corresponding feature points. With the OptSample policy, the reconstructed model seems to be unaffected. The third application is SLAM. We use TabMap as our SLAM algorithm. The network is disrupted several times. With native rows, a long segment of messages is lost and there are gaps in the mapped environment. With the OptSample policy, no such gaps can be observed. Thanks for watching.